We're going to start with what your paper defines a function to be. They say a function is special, but a function has special rules. It must work for every possible input value, and it has only one relationship for each input value. So the formal definition of a function relates each element of a set with exactly one element of another set. And so the way, again, this is their big time formal definition. For me, I say a function is a special relation where every input has exactly one output. Okay? That's really what's going on there. So this is a very common way to represent functions. It's called a mapping, where you're mapping one set to another set. So this here, these are my inputs, and they're being mapped to my outputs. You see how every input, I only have 5 inputs here, every input has exactly one output? Each input has exactly one output. This output has 2 inputs, doesn't matter. Remember how we talked about on the Coke machine? If this button always gives me this, it's okay if there's a second button that also is Coke. Remember we had...
Why is there 2 that don't?
Huh?
Why is there 2 that don't have anything?
Well, is every drink in every vending machine? No. All that matters is every button maps to only one drink. That's all that matters. Every input. It doesn't say every output, right? That's, again, all those words matter. Every input has exactly one output. Not every output matches. Okay? So when you look down here, there's the way they explain it. I've never used these words, but it might make more sense to you. 1 to many is not allowed. This one button gives me 2 different drinks. That's not allowed. But many to 1 is allowed. Okay? These buttons always give me the same thing, even though they both give the same drink. That doesn't matter. So again, that's one way you could explain it. I've never heard it that way until this book, but I mean, it makes sense. All right, any questions there? All right, so it's given me a relation. So all a relation is, remember I said a function is a special relation? All a relation is a collection of ordered pairs. So this would be a relation because it has 3 ordered pairs. So we're going to write this relation as a table, put it on a graph, and we're going to map it in a diagram. So let's first put it in a table. So we could have the ordered pair 2, 3. We could have the ordered pair 4, 7. And we could have the ordered pair 6, 8. There's my table. Groundbreaking stuff, right? Shoo. Now let's put it on a graph. This is always a good review. So where's the point 2, 3 at?
Over 2, 3.
Over. Which way over?
Right.
I'm going to go right 2, and I'm going to go up 3. So right 2, up 3. There is the point 2, 3. 4, 7 means we're going to go right 4, up 7. And then 6, 8, we're going to go right 6, up 8. It's hard to do on this. Questions there about on a graph? And then the last one is a mapping. So here's my rule on a mapping. Okay? It's going to work out just the same on this one. This one's kind of boring. But you should put all of your x's in numerical order, and you should put all of your y's in numerical order. So what is my lowest x value? 2. The next lowest, and the next lowest. And then same for the y. So put those in order. They go 3 to 7 to 8. and then you draw lines connecting which one goes where. So this one just works out that they're all straight across. Okay, but they don't have to always be straight across. Remember that drawing we looked at earlier? What's important is I want them in numerical order. Do you think you guys can do 2 through 4? Ready to go. One more thing I want us to look for is at the end, we just know this is a relation. I want to know, is this a function or not? So a function means each input has only one output. Does that happen here? It does. So this one is a function. So I want you to check that as well on the other three.